This video is based on investment appraisal and it's looking at net present value. So net present value calculates the monetary value now of the project's future cash flows. So what it does, it calculates or it predicts what the money could be worth in the future, because there's the understanding that money today is worth more than what it'll be in the future, and there's lots of reasons for that. Number one, it could be due to again uncertainty. We don't know what might happen in the future. Number two, we don't know what's going to happen in terms of economic policy. So, for example, interest rates may change, inflation may change. So what it does, it's just based on a forecast, a prediction, and this prediction is again based on discount rates. So the discount rates reduce future cash flows to reflect current interest rates or whatever they may decide upon. It might not just be interest rates, it might be anything that they may decide may change the value of money in the future. So as I've put here in the bullet points, it takes into account the time value of money. It recognises money received in the future does not have the same value as money received today. Again, which would, if I was to give you the choice now of having $1,000 today or $1,000 in 5 years' time, I can imagine all of you would want that $1,000 today. For many reasons, maybe $1,000 won't be as worth as much in 5 years' time due to inflation. Again, we don't know what might come up in the future, so there's the opportunity cost as well within that. So discounting is all about making an adjustment for having to wait for a return, so the inconvenience of waiting. Now, in terms of discount rates, there are steps that you need to go through in order to calculate it. So first of all, with discounts, they'll probably give you the rate. In fact, AQA will give you. So they'll tell you what the discounted factors are. Okay, so you'll get that. But in case they don't, and for example, sometimes in IB they might not, we'll go through the steps of being able to calculate the discount factors as well. But what you need for this is you need to work out the net cash flow for each year. So as I put here, multiply each year's net inflow by the relevant discount factor to calculate the annual discounted cash flow. You might be given the discount factor already. If not, we'll calculate this together, which we'll do. So you add up, once you've worked out the net cash flow, once you've worked out the discount factor, and once you've worked out the net present value, then you can start to calculate the cumulative net present value, which again we'll do within this video. So we'll go through an example and then we'll look at a past AQA question as well. So let's have a look at discount factors first of all. So imagine what we've got is we've got 4 different discount factors. We've got 2%, we've got 5%, we've got 7%, we've got 10%. In year 0, because you are receiving that money straight up front, you won't need to discount it, okay? Because remember, discount is only used when there's a time period involved. So for 0, it would all be 1, okay? But then what you'd have to get for year 1, you'd have to use the discount factor. So for example, what you do is you find out 2% of 1, you'd find out 5% of 1, 7% of 1, 10% of 1. Now we know 2%. If we were to convert that into a decimal, we'd get 0.02. So what we'd do is we'd do this really simple calculation. So you'd simply do 1 divided, so obviously that's the year, divided by 1.02. And that would get us 0.980399216. Now, if you wanted to do the rest for year 2, year 3, year 4, what I would do is I'll just keep pressing equals. So if I did it again, 1 divided by 1.02, press equals again, I'd get 0.96116878. Do it again, I'd get 0.94232233. Did it again, and I'd get 0.92384543. So they would be the discount factors. And now you could just round it, so you could just do it 0.98. And if you were to do it again, let's say, you could do 0.961 for year 2, and so on. So have a little go at doing that for 5%, 7%, and 10%. And like I said, all you have to do is once you've got that initial sum, And once you've got that initial answer, just press equals for the second one, press equals again for the third one, and press equals again for the fourth one. So let's put this into practice in the example below. So we've got an example here, and what we've got is we've been given the discount factor, which is 10%, and we've been given the annual cash flow for each year. Okay, so I know 10% as a decimal is obviously 0.1. So I've done 1 divided by 1.1 equals 0.909, and that's round to 3. So again, what I'd just do for year 2, I'd press equals again, and that would get me 0.826. And then keep pressing equals. So if I press equals again, I'd get for year 3, 0.751. Press equals again, 0.683 for year 4. Press equals again, 0.621. So now I've got my discount factors. So again, all I have to do is the following. So all I'd have to do is minus 50 times by my discount factor of 0.909, and that gets me that year minus 45.45. Okay, so what it's trying to say is in a year's time, that minus 50,000 is not going to be worth minus 50,000, and so on. So again, if we have a look at year 0, what we do is 500,000 divided by 1, and that'll just get us minus 500,000. So let's keep on having a look at the rest. So that's what we'd get if we did the calculations for the rest of them. Alright, but now what we need to do is we need to do it as a cumulative net present value to give us the final amount. And if you added them all up, what you get is you get from minus 500,000 to 679,950, and you can have a go at just adding them all up. But what we're going to do now is we're going to do an AQA question where you can see this better in practice. So this was an AQA question. The finance director has advised Kate the chocolatier's investors would expect her proposal to achieve a net present value of at least 40 million and a payback within 3 years. Using the data in Appendix B, Table 3, calculate the net present value and payback for Kate's proposal. State whether it meets the expectations of chocolate's investors. So obviously we're just going to look at net present value. There is a video on payback as well, if you have a look at the channel. So we've got, as I've said, AQA will give you the discount factor. So what we've done is they've given you a 5% discount factor. And again, if you wanted to know how they've worked that out, you simply do 1 divided by 1.05, and that'll get you 0.952. Now they've rounded it to 2 decimal places. Again, they've pressed equals, you get 9.90. Press equals again, 0.86. So let's have a look at how they've done this. So year 1, you've got your inflows, you've got your outflows. Year 2, you've got your inflows, your outflows, and so on. But what you need to do is work out the net cash flow. All right. So what I've done is I've created a little table underneath, which I'd recommend if you were to have a go at this question, and you wanted to in a planned approach, then I would do something similar. So what I've done here, okay, I've worked out what the cash flow is. So obviously in year 0, it's minus 500 million because what they've done is they've invested in. Does it say where it's invested in? Okay, well, you'll have to read the case study for that and find the case study, but they've invested and the investment has cost 500 million. In year 1, they expect a net cash flow of 145 million. Year 2, 217.5. Year 3, 265. The discount factors obviously in 0. Remember, it's 1 because you get the full amount back because it's there and then. In year 1, it's 0.95. Sorry, that's in year 0. In year 1, 0.95. Year 2, 0.90. Year 3, 0.86. Now, your net present value in year 1 is minus 500 times 1, which obviously equals minus 500. Now, what I'm going to get you to do is I'm going to get you to have a go at the rest yourself, okay? So if you want to pause the video and have a go, if you're a little bit stuck on how to do it again, I'll put the calculations to the side so you can work it out. So there you go, your net times your discount factor. So have a go, do your net present value first, and then what you can do is you can work out your cumulative net present value from that. Right, so you should have your answers now. Let's check them to make sure they're correct. So in year one, you should have got a net present value of 137.75. If you did 145 times by 0.5, that should have been your answer. For year two, you should have got 195.75. So again, 217.5 times by 0.90 should get you that. For the next year, you should have done 265 times by 0.86, and you'll get 227.9. Now, if you work out the cumulative, so you do minus 500 plus 137.75, you should get minus 362.25. If you add that to 19575, then you should get minus 166.5. And then finally, if you add the final net present value, you should get 61.4 million. So what you'd write, obviously, you'd show these calculations, you'd put the answer, 61.4 million, and then you go back to the question. You'd see that they expected a net present value of at least 40 million, so you'd mention that this exceeds the target of 40 million.